Hello and welcome to my video today. Today I'm gonna go over ROS2, robot operating system. I did some tutorials from YouTube. The channel is called Articulate Robots. From the guy from Australia. I'll link it in the description there. It's pretty good. He had lots of tutorials, lots of like a playlist for a specific build that he did, and it was a mobile robot. And yeah, I just kind of like followed it for the example. And yeah, I'll get the simulation running quickly here. So no, I want this one. Oh, wait. Just copy this. Oh wait, it's already here. That's why. Here, okay. So it's running, but it's closed. So exit this, and then we launch the launch file, and then in this world that's saved here. And I'll go over the code a little bit in a sec. I'm just gonna launch the simulation, and this is a gazebo. And gazebo is used for simulating. And then they have there's other ones called RViz for like visualizing. So I'm just gonna do this because I have where is it? Would be this one. Yeah. So here it's called teleup twist keyboard. So I can use the keyboard to control the robot. And we have this little simulation here. And yeah, you can set up a controller like a Xbox or a PlayStation controller, which would be a little more practical, obviously. But this one works just for testing. And yeah, so this is a simulation that if it was all set up and I was controlling it, it would be in the real world, but this is to simulate it. So you can see it. And then there's RViz, which is used for visualizing, and then also like putting in different peripherals, like here, I'll show you here. So we have, right now it's set up for a little camera view. So you can see, zoom in a bit. So here we have the main chassis, the wheels, and this is like a LiDAR sensor. That's what's up. And I never built it in the real world, but in the tutorial he has this LiDAR sensor, and here it's visualizing in a camera, right? So you can have different like computer vision to detect an object, to follow it. And this is the one that's turned on right now, but you can also turn on the LiDAR visualization. So it shows where it sends it and then bounces off these obstacles. So we can drive around a little bit. See it as a little camera visualized. And yeah, and to make these shapes, you just use the code. And you make like a cylinder. I can show the code, but make a cylinder, and then you have to like offset it from the center, from the X and the Y. And you can of course find like pre-built shapes. Like I found like a 6-axis robot arm that you can control through, just find it on GitHub or something. But this was cool because you got to make the shapes from the actual code. And then so that's what this example is doing right now. Before, I also had it set up with RViz. It could be using the LiDAR, and it's called Nav2 and SLAM. So it creates its own map. I don't have it set up. I might have to get it set up and then film again here, but I'll just describe it quickly. It creates a map. It has to drive around using the LiDAR, creates a map, and then memorizes it, and then can create a path from these low-cost zones away from the obstacle, and then you pick the direction and the pose, and then it'll drive there. I got that set up for next one here, next take or something. So we have, this is just my README file, so I can remember the launch commands, which is good. Sometimes it's hard to remember or know where to find them. And then we have a launch file. This is the spawn entity, telling to spawn the robot. And then this is diff drive spawner to be able to control it. Controller manager, see. And yeah, these are just control, and then it launches it. So it's just a launch file. Like you could do that all in a command line, you know. And then we have, this is the shapes and stuff. So let's see here, what do we have? This one, ROS2 control, gazebo systems. Okay. This is the main one, robot core. So you can see it has, okay, we have the white shape. Oh yeah, so you have the colors, you declare the colors, and this is XML, X acro, but like XML. You can just find the colors, and then you have the base link, base, so it's, again, I just follow this guy's tutorial, but you can see how you have to code like the actual positions and the shapes. It's a geometry box. In the dimensions, and then also like the offset, and then also I think here we have, so you have all of it for like the visualization, and then you have to do it again for the, I'm just trying to see here, caster wheel for the actual physics of it. So you have like the cylinder. Okay, you need to create it and make a shape for it so you can visualize it in Gazebo, and then you also need to make it again to make the physics so that it can turn how you want it. LiDAR, and I think, yeah, visualize false. So I put this to true, and then with the camera, we can turn this camera off. Camera visualize false. Okay, this, I can close this, and I don't know if I need to build it again, but let's see. Sometimes you do, sometimes you don't. So see what happens. Oh yeah, so I didn't have to, I guess, because I didn't like edit anything. I just kind of changed the settings. But let's open this up again. There we go. No, I don't want that. I want this, yeah. So I can zoom in. So we drive around here, pew, 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 and you can see the visualization of the LiDAR. Okay, it reflects off here, it comes back. So there's something there. And yeah, I can use this information to create a map and navigate it. And yeah, so obviously this is used in the real world, or like applicate like in our life often with like the Zumba robots, these autonomous and automations that are quite ubiquitous in our lives now. So pretty common problems, or pretty common solutions for our daily life, not just like a futuristic autonomous driving sort of situation. I think, yeah, I'm pretty sure the robots, the Zumba robots, vacuum robots, exactly this. They just use a LiDAR, create a map, and then they know where not to go, and then they can have different algorithms of like, okay, have I been there before? Is it dirty? You know, things like that. So pretty simple, but also complicated, obviously. And okay, here I have the SLAM toolbox and Nav2 working. So I have, this is RViz, and this is the simulation for the gazebo, and then this is to control it. So I can turn this one off. And each, so yeah, how this works is each of these, so I have this one to control it. I have RViz and then I have the gazebo launch of the whole project. But then then I have SLAM for the map is one node. So each of these are nodes to send like a topic, and then in there you subscribe to that topic. So this one is like the main one. This one was the SLAM toolbox. This one's the navigation, Nav2. This one was RViz. And yeah, so, and then this one was this twist mux to transfer it using, for differential control to subscribe. I don't know. I think you just have to do it to make it work. It's just like these under the hood calculations for making it move from the rotations. So if I go like this, you can see that the map isn't quite built yet. So if I drive around, so I have to kind of, you see once it drives around, it knows more of the map of the area. So we see here is the real world, or the simulated real world, and this is the visualization to have settings and do what you want, you know. So I can drive around, and it builds this map. But what's cool that I want to show is if you go like this, okay, I want this pose, so this spot in this orientation. Okay, well, how do I get there? Let's figure it out. Let's drive there. And then, yeah, autonomously go. So it can use what the map it knows, and also it can use like it scans and updates as well. And so how this works, from my understanding here. Turn this one off. Color scheme. So this is, try this again. Oh yeah, here it has this cost map. So it's is it stuck? Is it? Maybe it can't figure it out. But yeah, so you have this obstacle. Oh yeah, now it's going, and it knows that this is like high cost and then low cost. Okay, now it knows more. Okay, let's figure it out here, and go in between here, the low cost, and this is like free, you know, no cost, but this is high cost. So it doesn't want to go there. Seems to be can't figure it out. I guess maybe it doesn't know the map enough. Like it's better to kind of build the map better. But pretty cool, pretty cool. Because it's, can I control? I think I can still even control it, even if I, yeah. Maybe I can try to build the map a little better. But it's pretty cool. I like it definitely has a lot of, like I said, these nodes to build it. But once for me, it works just to like save the commands in the README file, and then I can, okay, launch this one, launch this one, launch this one, and that works pretty good. Let's try the goal pose again. Here. Okay, it's going, avoiding the obstacle. Okay, nice. Yeah, so it's pretty cool, pretty powerful little program here. Mobile drive bot. Yeah, if I go like this, it's pretty simple, but maybe I need to have a better obstacle course. You can see here. Let's go here. I think I need to explore the map more, and then I can make better decisions of the optimal path and the where to go. So let's see here. It takes a second. You go to the spot. Okay, no, just find more. But yeah, pretty cool. Anyways, yeah, let me know what you guys think. Comment below if you've used this before or wanted to get started on it or wanted to see it for different applications. And yeah, thanks for watching. Until next time, and bye for now.